Hey, what's up everybody? I'd like to welcome you to another Juce tutorial. And in this Juce tutorial, what we're going to talk about is smoothing out a problem that we're having with our oscillator at the moment. So for anybody who's been following along, you may notice that there's a small clicking sound that happens whenever you press or release a note. And a couple people have brought this to my attention, and something that really puzzled me for a while on why this was actually happening. And luckily Zanakios from the Audio Programmer Discord actually helped shine some light on what we need to do here. And I thought about it a little bit further and did some more research, and now I'm going to share that with you, and it was a real learning experience for me. So before we get started, let me tell you about the Audio Programmer community on Discord. So now we have over 5,000 members in our Audio Programmer Discord, and these are developers of all levels who are all trying to make their own audio apps, audio plugins, and just learn more about digital signal processing and audio programming in general. So you can come join us for free. We're on the audioprogrammer.com/community, and I'll put the link in the description below. So let's go ahead and get started. And currently, at the moment, we're in our synth voice class. So this refers to the actual voice of the synthesizer. And we only have one voice that's playing at a particular time. So I had this maybe naive understanding that originally that when you have the audio callback that's happening in our main process block, in our processor, I was under the impression that when we call synth render next block, that what would happen is that this would just take your whole buffer and it would process the synth audio or the voice audio from 0 to whatever buffer.getNum samples is, and that would be the end of the story. And so that's why we have the synth voice render next block code as it is, because there's this assumption that we're going to go from 0 to buffer.getNum samples, whatever that might be. And that's not exactly accurate at all, because we have one small caveat, which is that we have these MIDI messages that we're doing. So when we press a key, it sends a MIDI message, or when we release a key, it also sends a MIDI message as well. And the thing is that doesn't just happen at sample 0 in an audio buffer, right? You could press a key at any time in your audio buffer, and it needs to know where in the audio buffer that key has been pressed, and then it needs to be able to respond and start the note or stop the note or do whatever it needs to do where at the appropriate position in the buffer, not just from 0 to getNum samples, right? So we need to account for that, and so we have this process of offsetting that actually happens in our audio buffer when we get these MIDI messages in, and I'll show you how that happens. Another thing that we need to consider, and the reason for the clicking itself, is that we are taking we're taking our output buffer, and the problem is that when we get an output buffer into render next block, what may be happening is it may already have audio in the process block. There may be something that's already happening in our process block, and the problem is that if what we're doing is we're taking our whole process block and we're putting it into, we're actually applying this process of processing the oscillator, processing the gain, applying the ADSR to the buffer, and things like that. But the problem is that if we have a note that's in the release stage and that we need to play another note, what's going to happen is if we're applying this to the same buffer, then what's going to happen if the phase of our sine wave currently isn't at 0, let's say it's at negative 0.18, and that when we start the phase of the note that we play at that particular time, which is at 0, you're going to get a disjunction between that negative 0.18 and the 0 of when you're pressing the next note. And that's why you get that clicking, because what's happening is that the buffer is playing a certain note, and then when you're starting off another note that's at 0, it's saying, hold on a second, our note isn't at phase 0, so you're not going to get that smooth kind of transition between when one side note is done playing and when you actually hit the next note, and you're going to get that clicking. So to solve that, what we need to do is we actually need to create another audio buffer, and then what we're going to do is we're going to take the oscillator code and the gain code and the ADSR, and we're going to apply that to the to this other buffer, and then we're going to add that that information to our main output buffer. So if our output buffer already has audio information that is inside of it, then what it's going to do is it's actually going to change the positions appropriately so we don't get that clicking. Okay, so I hope that I've explained that properly. So let's go ahead and just create another audio buffer, and we'll do this. It'll be Juce audio buffer, and this needs to be, we need to declare what type this is. This is of type float, and I'll call this Synth Buffer. So let's look at the documentation again and see what it says, because it gives us some great clues on what we need to do. So once again, it tells us exactly what we need to do here. It says the output audio data must be added to the current contents of the buffer provided, right? So that's why we're saying that we need two different containers of audio information in order for this to work properly. And so now what we need to do is we need to one of the biggest mistakes that we have when it comes to audio buffers and taking one buffer and taking the information, moving it to another place, is that a lot of people, they forget to set a size to the other buffer. And normally you would not call a method like this, right? So we have our synth buffer. I think I call it synth buffer, and then we have set size. So normally something like this would not be allowed in an audio, in something that's being called by the audio thread. Okay, but in this instance, we actually have some help from the Juce team, where they've actually been able to make this where the audio buffer doesn't allocate every single time that we're going through the buffer, unless it needs to allocate a little bit more memory to account for the size that we need. You'll see what I mean in a minute. So set size. So we see that we have this audio buffer.set size, and this is where we're going to put our synth information, right? And what we see is that we have these optional flags here. So we have one flag that says keep existing content, which is something that we don't want to do because we want to replace the content every single callback. And then we have this Boolean called clear extra space, and we can see what that means here. If clear extra space is true, then any extra channels or space that is allocated will also be cleared. If false, then this space is left uninitialized. And then we have, if avoid reallocating is true, then changing the buffer size won't reduce the amount of memory already currently allocated, but it'll increase it if we need more. If it's false, then a new allocation will be done. Okay, so we don't want any new allocations in the audio buffer. We do not want that to happen. Okay, so what we're going to do is we're going to say synth buffer.set size, and then for our new number of channels, we just want to get how many channels that we have in our main audio buffer. And then for new number of samples, we will just put num samples. And then we will actually use these flags. So keep existing content, we want set to false. Clear extra space, we want we want to be set to false as well. And then we definitely want avoid reallocating set to true, because we don't want to reallocate any more memory every time we go through this audio callback. Only the minimum. So if our number of samples happens to be larger than whatever the size is that we have, then it'll just allocate just enough to account for those additional samples. So now we're setting the size of the buffer. And one thing that we want to do is we want to make sure that we clear this out every single time we call render next block. So we will say synth buffer clear, and then we will put the new information into our synth buffer. So what we need to do is we need to make our audio block a reference to synth buffer rather than output buffer. And then we're going to put in the oscillator information, we're going to put in the gain information, and then we're going to put in the ADSR information. Okay, and this needs to be synth buffer as well. And then now what we have is we have our information that's in our synth buffer, and what we need to do is we need to add it to our main output buffer, which is coming in from our processor. So just to show you again, so we have our process block, and this is our main process block, our main audio callback, where we have our audio buffer, and then we're taking the audio buffer and we're putting it into render next block. Okay, so that's why we have this output buffer that's coming from our processor, and now we need to add our synth buffer to our output buffer, just in case output buffer already has some sort of audio information in it. Okay, so what we need to do is we need to go through each channel. So we will say for int channel equals 0, channel is less than output buffer get num channels plus channel. And then what we could do is we can use the audio buffer method called add from. So we need to use, there are two ways we could do this. We could use either one of these. I'll show you the longer one. So I think we need the longer one in this case. So this is add from, and this is where we add samples from one buffer to another. And so once we do that, then what's happening is that we're actually resetting. If there's audio that's already inside of the buffer, then what we're doing is we're readjusting so we aren't getting those really annoying clicks in our buffer. So what we will say is output buffer add from, and we'll use this really long one here. So destination channel, so we're iterating through the channels, and what we'll put in here is channel. So destination start sample will just be start sample. And then our source, so we need our source here, which is synth buffer. And then source channel, once again, is channel. And then we have source start sample, which is going to be 0. And the number of samples, which is going to be num samples. Okay. Now, what's interesting is that, like I said, it can be quite confusing, and it confused me for a while. When you look at your processor and you see synth.renderNextBlock and you say, okay, I'm inputting a 0 and I'm inputting buffer.getNumSamples, and then when I go to synth voice and I'm getting this, I'm getting start sample, which would be, you would think it would be 0, and num samples would be just whatever buffer.getNumSamples is. But that's not quite the case, okay? And I'll show you that right after we do a couple other things, okay? So there are a couple other things that we need to do here. One of which is we should go back and we should read the rest of the documentation here, because there are a couple other things that we need to do. Okay, so there's one that says if the voice is currently silent, it should just return without doing anything. Okay, so let's do that, right? So there's a Boolean called, I believe it's called is voice active. So we can say if not is voice active. So if we don't have any voices active, we can just return, which means that it will just return out of this method without calling any of these other parts of this method. Okay, and then we also have, actually I'm going to do this over here. So let's see what else. If the sound of the voice finishes playing during the course of this render block, it must call clear current note to tell the synthesizer that it has finished. Okay, and we can do that by saying if ADSR is active, not. So if our ADSR is not active, then clear current note, which will reset the state of our voice if our ADSR is not active. I also decided to add something up here in our stop note where we could say if we don't want to allow a tail off, or if ADSR is not active, or is active not, then we can clear current note. And I will just do that just so we keep the conventions the same throughout. Okay, there we go. So I think we're okay now. One other very obvious thing that we need to do that we haven't done yet is we haven't given our ADSR any sort of parameters. Okay, so a little bit later we'll actually attach this to our value tree, but for now what we could do is we could just set some default parameters for us to work with. So we have ADSR params, which are our parameters for our ADSR. So we could say ADSR params.attack. We'll just set some arbitrary values here. So let's just say 0.8 and then params decay equals 0.8 again. We'll set our sustain to 1. And then we will set our decay maybe to 1.5 seconds. And now we need to do one more thing before we get moving, which is that we need to give our ADSR object our new parameters with set parameters. Okay, so we would just take the ADSR params and put it in there like so, and we should be okay. So here we go. Hopefully the sound of the synth is loud enough for everybody. So here we go. And once we've done this, we will investigate, and I'll show you some other things that I learned here about this. So now we have our synth. So it doesn't have a UI yet. So here it is. And if I hit this key, we got a problem. Okay, so let's investigate this, because this is related to what we what we were talking about before. So let's have a look at where this happened. So this happened in our apply envelope to buffer. Okay, so actually this needs to be ADSR or synth buffer get num samples. Okay, so, and this needs to be 0, okay, because this is applying to, this is of course applying to our synth buffer. Okay, so we don't want to mix up start sample and so anything that we're applying to our synth buffer should go from 0 to synth buffer.getNum samples, but anything that we're applying to our output buffer should apply from start sample to num samples. And you'll see what I mean in just a minute, why that needs to happen. So very easy to get this confused, and it was quite confusing for me as well. And I will show you a little bit more about why that needs to happen, or about the reason that this is so easy to get confused. So here we go, back to our synth again. Hopefully this will work. Here we are. So I hope you can hear that. But you can hear no more clicking. Great. So that problem is fixed now. So we don't have that clicking anymore. That's really annoying. So now let's go a little bit deeper and let's have a look at what happens here. So what I will do is I'm going to first say, so as I said before, one of the big keys about this is that when we call render next block and we give it arguments of 0 and buffer.getNum samples, we assume that when we actually go to get next, when we actually go to render next block, which is calling in our synth voice, that start sample is still going to be 0 and num samples is still going to be output buffer.getNum samples, but that's not correct. And this goes back to what I was telling you before. So let's just set a let's set the application to pause if start sample is not 0. Okay, so we'll say something like if start sample is not equal to 0, then we'll just call jassert false, which will actually pause the execution of our plugin when this is called. And then what we can do is we can look through the call stack and we can actually inspect what is happening. Okay, so there we go. We're going to call this again. Here we have our synth. Okay, it's running fine. Hasn't broken yet. But now I'm going to hit a key. Now I'm going to hit a MIDI key. And now we get this breakpoint, jassert false. Okay, so now we're in debug mode where we can actually just look through this and see kind of what's happening here. So first thing that we want to do is we want to look at start sample, right? And we can see that start sample is actually 237. Okay, so that's where our sample, that's where our start sample is. And we can look at num samples. And num samples is 19. So it looks like our total buffer size is 256 samples. Okay, so we're actually going from 237 to and we're only going 19 samples in this particular instance. Now we can look through the call stack. Okay, so let's go all the way back to where we're actually calling this from the processor. Okay, so we can go back to where our process block was actually called. And now we can look through and we can actually just process this step by step and see what's happening. Okay, so in render not, when we call synth.render next block, we are starting from 0 and then we have buffer.getNum samples. So let's see here. So if I go down here, buffer, I hope you can see this actually. So we see that the size of our buffer is 256 at this particular moment in time. Okay, so synth.renderNextBlock calls synth.renderNextBlock, right? And then we look in here and we see start sample is 0, and we see num samples is 256. So far so good. Okay, so the question is, how do we get from 0 to 250, from where our start sample is 0 and 256 to where it's changing in renderNextBlock? So let's see where this actually happens. So now renderNextBlock is calling processNextBlock, and now we have this processNextBlock. Okay, and now we have this Midi Iterator find next sample position and start sample. Well, this is a bit misleading because start sample at this particular moment, like when this first called before, at the current time it's 237, but when this, before I hit the key, the start sample was actually 0. So what happens is that this Midi Iterator actually looks at where in the buffer we were when the key was hit, and actually applies an offset in order to calculate where in the buffer, where in our audio buffer we hit the MIDI key, and how many samples we need to process to get to the end of our buffer. So that's the reason why when we go to render, when we get to this line 177, we have our start sample at 237, which is saying, okay, when you hit that key, you were 237 samples into your callback, and the number of samples, which is 19, and which means, okay, you're 237 in, and you have to process 19 samples in order to get to the 256 samples. And then from there, it calls voice.renderNextBlock, or voice renderNextBlock, and that's how we got to where we actually are in our synth voice, and we call renderNextBlock, and we're ending up with our start sample at 237 rather than at 0, because our Midi Iterator is actually saying, hold on a second, you aren't, when you hit that key, you weren't at position 0 in your audio buffer, you were at position 237. So that's why that's happened. Okay, and I will show you one more thing just to take that home. Okay, so if we go into our, so let me go back here, and actually I will just keep this there for now. What we'll do, and we're going to have a tutorial coming up soon where we actually talk more about the MIDI buffer class and how to use this. But there's a little handy piece of code in here that we can just throw in here really quick, which is MIDI Buffer Iterator. So you have this MIDI Buffer Iterator class, which has been deprecated, and this has been deprecated in favor of MIDI Buffer Iterator, okay, which is not in a separate, which is not inside the MIDI Buffer class. It's a whole separate class. And in here we have this kind of handy little piece of code here to actually get the description of a MIDI message. So this will actually get the information from any MIDI message that we send, because it needs to know when we press the note, how hard we press the note, what note that we actually pressed, and so on. Like I said, we'll do a separate tutorial in the future with my friend Eyal Amir, and we will actually go a little bit further into how to actually use this. But for now, this will just knock home what I was saying about timestamps. So we have a couple errors here. So these are Juce objects, so we just need to precede them with Juce, like so. And then what we're going to do, so all this is doing is this is going through our MIDI buffer, which is looking out for any MIDI messages that we might be sending from a piece of equipment, or in this case, my keyboard, or from a MIDI controller, and it's basically getting us the description. So I'm just going to change this to get timestamp. Okay. Now the problem is this returns a double, and write to log needs a string. So all I'm going to do is I'm just going to wrap this in a Juce string, like so. And then I'm just going to put a little precursor to that, and I will say timestamp, like this, and a little plus, and we should be good to go. So what this will do is, if it's receiving a MIDI message, it will show us the timestamp of where in our buffer that has actually happened. Okay, and I will just show you what I mean here. So we're just going to compile this. It's interesting because my computer is blazing fast today, which is quite unusual. Okay, so here we go. So now we're going to pop open this VST3 and back into our synth. And here we are. Nothing here yet. And then you're going to see that I'm going to hit a MIDI note, and we should get a timestamp here. Okay, and so we see that we got the timestamp, and it says 224, right? And that means that when we hit that key, we were 224 samples into our audio buffer. So that's why our start sample is 224, and why the number of samples is going to be whatever 256 minus 224 is, which is going to be 32. So that's how many samples that we would have to process in that particular callback in order to actually get to the end, rather than trying to go from 0 to 256 every single callback. Okay, so that's the reason why, because if we hit it in the middle, if we hit a key in the middle of our callback, then we don't want a situation where either A, we need to wait to the next callback where it registers that we've hit a key, or B, where we're trying to process too many samples at once. So if we're in the middle of the callback, then what we need to do is we need to offset and subtract however many samples in we are from however many samples there are in the buffer, which will tell us how many samples we need to process. I hope that's not too confusing for you. So yeah, I hope that was helpful for you. Some people asked me to go a little bit deeper on some of these tutorials, and so I hope that this was helpful in understanding what's actually happening, because I know it was very helpful for me. Thanks once again to the people that help us in the Audio Programmer Discord, people like Xanakios, Yalamir, and who help us understand these tough things. So if you like that and you found it helpful, please be sure to like and subscribe, and I will see you next time.